In this tutorial, we're going to find the Laplace transform of f of t, which is equals to 6 multiplied by exponent of minus 5t plus 3 exponent of 3t plus 5 times t cubed minus 9. So to find that Laplace transform, we are going to use the tables. The Laplace transform will denote it by f of s, and we would have the Laplace transform of 6 exponent of minus 5t plus 3 exponent of 3t plus 5 t cubed minus 9. At this stage, we can now use properties of Laplace transforms, the linearity property, and when we apply that property there, we have a Laplace transform of 6 exponent of minus 5t plus a Laplace transform of exponent of 3t plus Laplace transform of 5t cubed minus Laplace transform of 9. But we can use another property again of Laplace transform where you can factor out those constants, the 6 there and the 5 and that 9. And we would have 6 Laplace transform of exponent of minus 5t plus Laplace transform of exponent of 3t plus 5 Laplace transform of t cubed minus 9 times Laplace transform of t to the power 0. For the last one there, we were having Laplace transform of 9. So when you factor out the 9 there, it's a constant, we remain with a 1. But 1, we can write it as a function of t. And as a function of t, that's why we put t to the power 0, because t to the power 0 there is a 1. So that's what we are having there. And we now go on and use the tables to find the Laplace transforms of each of those functions. So when we are using the tables there, I'll start by looking at the first one there, of the exponent of minus 5t. What you do is we look at on the table there, on the column where we have the f of t, we look at a function which is of the form of exponent of minus 5t. And we see that it's of the form exponent of at there. And by comparison of the function that we have and the f of t we have in the table there, we see that our a is a minus 5. So if a is minus 5, we substitute it on the f of s there, and we have our f of s is s minus 5. And that will simplify to 1 divided by s plus 5. So we'll write it the 6 times 1 divided by s plus 5. So we are done for that one. We go on to the next function. That's the exponent of 3t. The exponent of 3t there is of the form exponent of at. And in this case, by comparison of those two functions, we see that a is equals to 3. So we go on and substitute a equals to 3 on the f of s on the right there. So we would have f of s is 1 divided by s minus 3. And we'll substitute it there, so we'll have plus s minus 3. We go on to the next part there, where we have the t cubed. The t cubed, now when we look at the f of t in the table there, we see that it is of the form t to the power n. And by comparison of those two highlighted functions, we see that our n is equals to 3. So we substitute n equals to 3 on the f of s there. We would have 3 factorial divided by s to the power 3 plus 1. 3 factorial gives us a 6. So that will simplify to 6 and divided by s to the power 4. And I substitute it above there, and we have 5 times 6 divided by s to the power 4. And now for the last one there, we are now looking at the t to the power 0. The t to the power 0 there is of the form t to the power n, and by comparison of those two highlighted functions, we see that our n is equals to 0. And if n is equals to 0, we substitute it on the right there where we have our f of s, so we would have 0 factorial divided by s to the power 0 plus 1. 0 factorial is a 1, so that will simplify to 1 divided by s. And I substitute it above there, and we have 9 times 1 divided by s. So what we are having there is the Laplace transform of that given function is 6 times 1 divided by s plus 5 plus 1 divided by s minus 3 plus 5 times 6 divided by s to the power 4 minus 9 times 1 divided by s. And we can just simplify by multiplying throughout by those constants there, and it will simplify to 6 divided by s plus 5 plus 1 divided by s minus 3 plus 30 divided by s to the power 4 minus 9 divided by s. So that's the Laplace transform of the function that we were given.